So what I'm going to do is I'm just going to put you in groups, and then I'm going to give you an activity to do. The activity has to do with carrying capacity. It's really simple. We're not graphing anything out now, but we're going to just be looking at graphs of the population and the carrying capacity and asking, there's a couple of questions that you then have to answer. And then what we'll do is we'll go, all right, so are you guys finished with that? We can go through some of the answers, see what everybody came up with. All right, so does anybody want to give a definition for carrying capacity? I mean, it says come up with your own or write your own, but I know we went through it before lunch, and I know it's right in the notes, so maximum number of organisms in the... Okay. And then what are some things that the carrying capacity depends on?
We did it broad. We said abiotic and biotic factors.
Very true. Everyone else got that? Yes? All right. Any other factors that you think? Yes?
We said competition or disease or temperature, anything that would affect the population size or the resources.
Right, and so a lot of that would, well, yes, that's absolutely true. And a lot of those, like biotic and abiotic, would go in number 2. And then, like you were saying, with the disease, for like number 3, other things like natural disaster, human impact, like pollution into the environment that can then affect the carrying capacity and affect the population. Okay. All right, so then they asked a couple of things in question number 4, based on the statement that the carrying capacity of a lake is 150 minnows. So can you have less minnows than that in the lake? Yes. Can you have more? Yes. Yes, exactly. So it should stay stable right around 150. So no would be the answer, but what we see in a natural ecosystem is that there is some fluctuation. Sometimes it might be a little bit more, a little bit less. That's okay. And then if there are 140 minnows in the lake, when the amount of resources in the lake decreases, so the carrying capacity drops from 150 to 100. So what will this do to the population of 140 that's in there? Decrease it, right. And why?
Resources.
Not enough resources. Right, right. So we need to get down to what the new capacity is too. All right, and then for the graphing, just kind of looking at the graph A, what is the approximate estimate that you have for carrying capacity?
50.
Yes, around 250. And then during which year did the population reach the carrying capacity?
Almost 3.
Yeah, just about 3. And then how many years did it stay there?
4 years.
Yeah, about 4-ish. Yeah, years. 3, 4, 5. Yeah. What are the carrying capacities if we look at graph B? We see something a little different.
It's 2.
2, right? So I heard someone say it. Right, so around 200 for the first and then around 100 for the second. How many years did the population spend at the first carrying capacity?
2.
2. During which year did it reach the next carrying capacity?
4.
Good. And then of those 2 carrying capacities, which one is more stable? Second one. And why?
Less fluctuation. Longer time.
Yes. Yep. Longer time, less population. Excellent. All right. So this is an activity, I don't know. I know you guys all do high school, so I don't know if this would be not as challenging for the high school students. One of the high school teachers in the last class suggested maybe doing it as a bell ringer, like something that they do as soon as they come in to review concepts that maybe you went through previously. I don't know, maybe this is a little bit more middle school if they're doing ecology. But then you can also show the students kind of a visual of what the carrying capacity is by looking at the bucket. You know, so you have this bucket, it can only be filled with so much water. Anything beyond that capacity is out of the bucket. So if you do that with living organisms, then obviously anything that can't fit in that bucket is not going to be able to survive in that environment. Okay. So I don't know, any questions about that at all? It's pretty straightforward. Yeah. All right. So then I have a second activity for us to do that I'm going to give you a little bit more time to do, because there's also graphing that we're going to be able, or that we're going to have to do, and that was one of the components that they wanted us to go, you know, over with you guys, is making sure that all the mathematical representations and the graphing of the ecological data. So this one includes that. This is using an example, and this is a real-life example looking at the Calabab deer population out in Arizona. And data that was generated back in the early 1900s. So in the handout, there is a couple of paragraphs explaining about the Calabab deer population, and then explaining what their carrying capacity is, and then some of the regulatory policies that were put in place in order to get it to its carrying capacity. But then what happened when those regulatory policies were put in place and what it did to the population. So you're going to have to graph out, so read the couple of paragraphs, and then you'll have to graph out the data that's in the table, and there's some graph paper up here, and then there are a couple of questions that you can then answer based on the information that's given in these first couple of paragraphs. Okay, so I'll hand out another one for each of the groups. Oh, sure. It's small, so you might have to like kind of get, or if you guys want to, I can hand out enough, and then if you don't write on a couple of them, then you can give them back to me, what you don't write on, because it's kind of small for everyone to be huddled over. No, one per group is fine. You can graph it together as a group. Yeah. And then whichever ones you don't write on, if you just hand back to me so that I have enough for the next group.
You put the air back on.
Yes, sure. Well, do you need one to read too?
Thank you.
What do you think? Oh, maybe high cool. Oh, that's what was on. Ah, there we go. I'll give you that, and then just hand it back to me when you're done. Do you want another one too? Sure. Sure. This is completely different for me because we just give like straightforward lectures, and then there's not really, in lab we do activities, but not in the classroom. So it's so different.
It's hard sometimes just to observe, and then you almost feel like you're just not working.
Yeah.
Blotting my participation.
Do you guys teach in the same district?
Yeah.
Yeah.
Same building.
Awesome.
There shouldn't even be.
Now, where do you teach?
Williamsport.
Williamsport. Okay.
It's like northeastern part of the state.
Yeah.
About an hour away from Harrisburg.
The Little League World Series.
Yeah,
I've been there. Yeah.
In college, when I worked other places and stuff, because I'm from Williamsport, that's all people knew about it.
Yeah. It's great. My kids go down like the Little League system that they're in does like a bus ride. It's like the best day. The kids love it.
Nice.
Yeah.
Now you know people from there.
Yeah. So are you guys bio or chem or what do you?
Bio, chem, physics,
Physics.
math, algebra.
Now, a little whatever. Social studies.
You have English? Practice what you preach. No. This would just be a rough draft. Yeah. Then we would do an index and all. Oh, there's questions. I
We go on word questions. Okay. During 1906 and 1907, which two methods did the service use to protect the deer? That was in the beginning, right? Wasn't that where they came off the predators? Yeah.
Yeah, it's like our grade now.
The first step was seven, the man.
population over, what did it say the carrying capacity was on? The average carrying capacity is estimated to be about 1,000.
So it's out here. So in the past, it's probably doing this. But they took the predators and spiked up. And
how they're using the term carrying capacity in this. Because they keep saying changes occur in the carrying capacity, and what was the carrying capacity like?
They estimated at 30,000.
At 30,000.
They estimated at 30,000, but that was just an estimate. It was obviously erroneous.
Right.
But this keeps saying things like carrying capacity of the range in these years.
Right.
Like, so, but shouldn't, carrying capacity is carrying capacity. It doesn't, it's, because you're eliminating all of the predators, changes the carrying capacity, but not really, because it's not a stable environment then.
Right. So they think they just want to know for those specific years what the population is. Right.
Do you think any changes occurred in the population on the range between blah, 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 not in the carrying capacity?
Right.
By taking away the predators, like that would affect the carrying capacity, I think.
Yeah, so it's almost like they're using it interchangeably.
Yeah, it's like they're
Yeah.
flopping back and forth because it is what it is. Like if you're teaching the kids,
If it's a stable.
if it's a bucket and there's
Right, and you
so much
can't
to
put
come out,
it, right.
why now all of a sudden are we, like, okay, this year is this, and this year is another, and that year is another thing. Like it seems
Right.
a little confusing.
Yeah, I think they're using that terminology interchangeably with just population size.
But yeah, that's I think would be a better fit.
Yeah.
Our last session, it's hot. These are, one of them does astronomy, one of them does physics, chemistry. One of them is short.
Some of those
Oh, I think
Sure. Are you guys almost finished with the questions?
just about.
Cool.
your last sessions are gonna be.
For these?
Yeah.
No, I don't.
I'm getting a migraine on the middle way now.
that
I
sucks.
teach chemistry and physics, so for chemistry and physics, I was just gonna go way down.
Yeah,
I think the best.
I know.
That's the best engineering.
Oh, I wanna go to that.
Last one is Paulson. I think he does chemistry.
chemistry. Yeah, I think
So
he
maybe I'll
does
just
do
leave.
chem.
I just skip out of cough now. I'm getting a headache.
All right, how about we start going through, because we're running out of time too. We'll go through some of the answers and we'll see what, and we'll see what everybody got for some of the answers. So in the first question, it asks, in the time period between 1906 and 1907, what were the methods that they used to protect the deer? Killed predators,
And they declared it like protected land.
protect the from the
So we could
can hunt, and the grazing animals.
that came later, but yeah.
And so then the second question, by not allowing them to hunt, preserving the deer, and also killing off the predators, were those methods successful based on what you guys graphed out? Did you see an increase in the population?
Yes.
Right? Okay. How many predators were eliminated? So they gave like a number as far as... Yeah. That's a lot of animals that they eliminated, which then we'll see caused that population explosion. So the relationship then for number 4 of the deer herd population size and the carrying capacity of the range. What did we see for that in 1915?
15 was down at the carrying capacity, then 2025, and then in 1920 it doubled, and 1940 tripled.
Yeah, so it heavily exceeded what they originally estimated to be the 30,000 for the carrying capacity. And probably a lot of that was due to removing those predators. So, based on that, did the Forest Service program appear to be successful with what their objectives were? Extremely successful, but then what happened to the population and the environment then after? I don't know if you would necessarily call that a success. So if you looked at the data that you guys graphed out, you saw it went up to like 100,000, tripling what the capacity should have been. So then we started to see a decline in 1925 after it reached that 100,000. So what do you think happened then?
Ran out of food.
Yeah. With that huge population, resources are going to become very scarce, depleted, right? So do you think any changes occurred in the carrying capacity in the range between 1900 and 1940? And what do you think happened?
They said the quality of the resources went down, so then I think the carrying capacity would naturally go down with the quality.
Right. And then why do you think the deer population size was only 4,000 in 1900 if what they were estimating that it could have been 30,000? Why do you think it was so low?
Outside factors from the other animals grazing.
Yes. A lot of the grazing animals, sheep and cattle, they were saying were kind of eating a lot of their food. So if the Forest Service had not interfered with the deer population, what do you think would have happened?
Might have died out.
Yeah, so it could have decreased the population and stayed below what the estimated carrying capacity was. But what they did, I think, was so dramatic and so just over the top and extreme that,
They move so quickly, they didn't really let things.
yeah, kind of stabilize. So based on these lessons, suggest what you would have done to manage the population.
Could issue predator hunting tags, so that way you just decrease the predator population maybe a little bit.
Right, maybe in smaller increments. Right. Is that what you were going to say too?
I didn't quite hear it.
So he was saying put like an amount, like for hunting the predators, put like an amount on how much you can hunt. So then you eliminate just smaller percentages of the predator population.
Out of there, so they're not grazing.
Right, right.
We talked about jumping it so that like right before it goes to 30,000, which we know to be like the carrying capacity, to increase the hunting season of the deer so that we're kind of calling them down soon.
Right, before it gets out of hand. Okay, so one of the criticisms of population ecologists is that the pattern of population increase and then the crash of the population, they said, would have occurred even if a bounty had not been placed on the predators. So do you think that that would have happened? And if so, give a reason for that statement.
Well, the predators depend on the deer. So in order to increase the predators, you have to increase the deer. So the predators are just going to be behind the cycle. Like, so when there's too many deer, the predators are also going to spike, but they're going to spike like kind of like the next year. And then there's going to be too few deer. And so they're going to start falling back. So it'll still be there even if there's a number of predators.
Right. Were you going to say something, Dick?
Well, because they said they kind of gave them their own area, and then they eliminated hunting all of the deer in the first place, so that probably would have caused a spike here,
Right.
because they weren't getting hunted.
And then what future management plans would you suggest? I think a lot of things that we've already kind of said too, like certain tags for the predators, a specific number of tags for the deer themselves, the grazing animals. So, and then identify the dependent and independent variables in the interaction between the deer and their predators. Independent variable? What was that?
She said time.
Time. Yeah, and I mean, and the independent variable itself could be the predator itself, changing that, and the dependent variable being the deer, because that's what we're monitoring. So I mean, this not only, I mean, this is a good activity because it brings in information, it gives you a data table, it allows the student to then graph that, look at the data, and then even analyze the policy that was put in place, and you know, was it a good policy, how would they change it? And then one of the teachers in the last session that I had said that it would also be good to use something like this and then springboard off of it to then talk about the Pennsylvania deer population and what the Gaming Commission has done in order to change even Pennsylvania's own deer population, and how they restrict or increase the hunting and stuff within Pennsylvania. You can talk about that. I have a third activity too, but we're not going to have time to get to it, but I will post it on that wiki site because it deals with predators and prey also with deer, and asks the students to look at predation versus starvation of the deer population. And that's another thing that population ecologists also look at. So what's better? They go through an example where there are deer on an island and their population is increasing. And so in order to keep it at a good size, they introduce to this island wolves. To act as a predator to then kill the deer, because the deer are then starving and sickly and dying. So is it better to do that aspect and allow for the fittest deer to then survive and pass on with their offspring, or is it better to just let them starve out as a natural process? So in this activity, and again, we're not going to have time to do it, they again give data that your students can use, and then you can also graph out that data to see changes in both the prey population of the deer and also the predator population of the wolf, and see how they interact with each other. And then there are some questions concerning the data, and then also, again, what's best to do for the deer population. So I will post that also so that you can have that as an additional activity with this first one that we did. And so I have information on predator and prey interactions, which are obviously very important for the environment. Even what we just saw in the last activity that we just did, they're helping to provide ecological stability. They help regulate the impacts of grazing and browsing animals, and then ensuring overall productivity of the habitat. One of the purposes for the predators within the environment is that they help to cull any of the weak and sick and old prey, allowing the maximum fitness and survival of the fittest to then continue on. And with that, they also foster biological diversity. They enforce ecological boundaries, or preventing what ecologists refer to as competitive exclusion. And we're going to get into competition, not now, but in the next time that we meet, so that all of the same species are then competing with each other for the same resources. If we have a predator in there that can then help to stabilize and maintain the population, then we wouldn't see that competitive exclusion. And that would be the tendency of one prey animal to outcompete the other. And there are different levels of predation that we see. So the ones that we think of as the main predators are those like the wolves, lions, tigers, as part of the animal kingdom. They help to control the mesopredators, which are things like the coyotes, raccoons, possums, foxes. And when they're left unchecked, they can do enormous damage to other animals and then further affect the environment. So it's important to kind of keep that hierarchy of predation in place. So that would have led into that third activity that I just discussed with you, which I will also post. And then what we'll do next time when we meet, we're going to be moving upstairs to do a lab experiment and talk about the impact of human activities and talk a little bit about pollution. But I will finish up with this. We're going to go through biodiversity and a little bit about competition exclusion. And there's an online activity that we can do regarding paramecium. So I don't know, I'm going to see if maybe you guys can do it on your iPad. And there's data that you can graph out with the competition exclusion activity. And it goes along with some of the concepts that you'll be asked on the test. Okay, so we'll try to fit that in also with then the pollution experiment. Okay? Any questions at all? I don't know, any ways that you can see incorporating this type of information? I mean, this is my first time doing this, so if there's like, this is not what we do when we're here, please let me know. Because I don't see it for another day or two. I can try to alter some things a little bit so it's more suitable for